Alright guys, today we are looking at target 6b, and target 6b has to do with proving geometric theorems. Proving with geometry uses things that we've already learned, like distance formula and midpoint formula, but it also uses a lot of slope. So today, all we're really doing is a review of slope, which a lot of that you already know. So, slope, right, is the steepness of a line. A lot of us remember it as rise over run. The formula for slope is, right, m is what we use for slope. So slope equals y2 minus y1 over x2 minus x1. Again, this is one of those times where we always do the second first, the first second type of thing. Then if we're writing a line, the easiest way to write a line is slope-intercept form, right? That's that y equals mx plus b. A lot of us remember that. M is the slope, and b is the y-intercepts. And remember, y-intercept is where the line crosses that y-axis. Another type of way we have to write a line is called point-slope form. And I think this one might be a little bit new. We'll be looking at this one today. Y minus y1 equals m, which is your slope, times x minus x1, right? So it's called point-slope form because it uses your slope and a point. Mathematicians, we're not very creative with our names. Then we have four different types of lines we're going to be looking at. Parallel lines, and how you know lines are parallel is that they have the same slope. There's perpendicular lines. You know lines are perpendicular because they have opposite reciprocal slopes. The word opposite, in this case, just means that you change the sign. So change the sign. So if it's positive, it goes negative. Negative goes positive. Reciprocal means flip the fraction. So for example, a slope of negative 2/3 and a slope of positive 3/2, right? Different signs, flip fraction. Those are slopes that are perpendicular. Same thing with something like the slope is 4, the perpendicular slope is 1/4. Okay, so if it's just a number, it's 1 over that number. Sorry, forgot the negative. Negative 1/4, the opposite. Okay, so it's changing the sign and then flipping the fraction. All right, then the other two types of things we have are horizontal lines and vertical lines. Horizontal lines are lines of the form y equals k and have a slope of 0. Vertical lines are lines of the form x equals k and have an undefined slope. The easiest way to remember these two, there's two small little mnemonic devices to remember them. And that one for horizontal lines, it's hoy, like today in Spanish, yes, hoy. So the H just means horizontal. The O is the 0, right? So your slope equals 0. And your equation is y equals, okay? So if it's a y equals, it's hoy, horizontal, and a 0 slope. The B1 is not as great to remember, but it's plus dux. That's for vertical, undefined. And it's x equals. So if you see an equation on the line that's x equals something, it's a vertical line. So vertical going straight up and down. All right, so let's look at example 1. Example being these lines. So, looking at A. When we have something in slope-intercept form, we're always going to start with our y-intercept. So I'm going to start at -1. Then we have our slope, which is 2. Right? Remember, slope is rise over run. So it's going up 2, and since this is just a number, it's really 2 over 1. So every 2 it goes up, it goes over 1. Starting at -1, I'm going to go up 2 over 1. here. From there, up 2 over 1. Up 2 over 1. Up 2 over 1. I can also do the same in the opposite direction. I'm going to go down to left 1. So there's my new point. Down to left 1. Down to left 1. Okay. So I'm just going to draw this line as bad as it's going to be on my board. Oh, that wasn't too bad. Okay. Looking at B, same type of thing. Right? Plus 2. I get to start at positive 2 on the y-axis, right? Then y equals negative x plus 2. Remember, this is technically a negative 1 anytime you don't have a number in front of your variable. So, I'm going to do, from here, I'm going to go down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Then I can do the same thing. Up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, blah, 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 right on forever. You probably, for most times, you won't have to make all the points, as long as you just make up a few of them. Looking at C, y equals negative 3. This is a y. Y is in the word oi. So it's horizontal at negative 3. Right. So I'm going to go, in the horizontal line, so I'm going to go to negative 3. It's y equals, so we're on our y-axis, right? So where y is negative 3, and just draw that horizontal line. X equals 4, that's in the word sun. X equals, and it's vertical, right? So I'm going to go where x is 4, and I'm going to draw a vertical line. And that's it for drawing our line. All right, let's look at example 2. Example 2 is looking at whether lines are parallel, perpendicular, or neither. Okay? The easiest form for a line to be in, if you want to tell what its slope is slope-intercept form. We can easily see what the slope is. Okay? So for these ones, you're always going to put it in slope-intercept form. That's y equals mx plus b. Right? We're always going to have it at the form y equals mx plus b. Looking at A, what's great about this one is 3/5 already in, right? It's already in slope-intercept form. 3/5 is my slope for this one. Let's look at the second equation for this one, right? The only thing that's making it so that it's not in slope-intercept form is this 5, right? Slope-intercept form is y equals, not something y. So I need to divide both sides by 5, right? You divide everything by 5. Okay? So really all you're doing to get in slope-intercept form is solving for y, getting y by itself. Okay? My 5's cancel out. I have y equals, that's 3/5 x minus 2. I don't care what my intercept is to see if they're parallel or perpendicular. I only care about slope. So 3/5 slope and 3/5 slope, these lines have the same slope, therefore they are parallel. Looking at B, y minus 2 equals 7x. Right? This one is not in slope-intercept form. I have to add 2 to both sides. So y equals 7x plus 2. Here, my slope is 7. Looking at the second part, x plus 7y equals 8. Right? The first thing I have to do is move that x. I'm going to subtract x from both sides. 7y equals 8 minus x. Down a little bit, sorry. And then I'm going to divide everything by 7. So y equals 8, 7 minus 1, 7 x, right? Because technically that's a 1x. Now again, I only care what's in front of my x, and don't forget the sign. So m equals negative 1, 7. If I look here, 7 and negative 1, 7, those are opposite. Reciprocal. So these two lines are perpendicular. Alright, let's look at our next page real quick. Example 3 says, find the slope of each line and determine if the lines are parallel, perpendicular, and neither. So now instead of being as an equation, we just have them as points. So remember, in order to find our slope, m equals y2 minus y1 over x2 minus x1. Okay. So for line 1, we'll start there. I have x1, y1, x2, y2. Be careful with which one's which. So I'm doing 1 minus 2 over 3 minus 1, which is negative 1 over 2, and that can't reduce, so I'm done. Looking at line 2. I have 0 minus negative 1, and 2 minus 0. 0 minus negative 1 is 1, 1 minus 2 is 2. So, these two slopes are opposite signs, but they're not reciprocal. That means these two are neither. Looking at B, I have, right, x, this is our 1s and our 2s. So, y2 minus y1, that's 1 minus 3, over 3 minus 0, that's negative 2 thirds, that can't reduce. Line 2, I have negative 5 minus 4 over negative 7 minus negative 1. Negative 5 minus 4 is negative 9. Negative 7 really plus 1 is negative 6. That does reduce to 3 over 2. These are opposites, and they are split, so these are perpendicular. Alright, let's look at example 4. It says write the equation in slope-intercept form of the line that is parallel to y equals 3x plus 6 and passes through the point 4, 7. Okay. This one's nice because we already know our slope, right? Because I pull it straight from there. So slope equals 3. And since it's parallel, my new equation needs to have the same slope. Parallel lines have the same slope. So then, right, I need to use, now I have my slope and a point. So I'm going to use point slope form. And again, not very creative. Point slope form is y minus y1 equals m times x minus x1. Okay? So I have y minus, my y1 comes from this, y minus 7, equals my slope, which is 3, times x minus my x is 4. Okay, so I'm really just plugging my numbers into this equation. Not particularly close. And then I'm just solving. I'm going to start by distributing my 3. Y minus 7 equals 3x minus 12. Solving for y, I'm going to add 7. Y equals 3x minus 5. Okay? So these two lines are parallel. This one passes through that point. Very quickly, our last problem, example 5. Same exact thing, except now it's asking to be perpendicular to this slope, right? -5. So if my first slope is -5, my perpendicular slope, right? Change the sign, it's going to be positive, flip that fraction, it's going to be 1/5. So now again, I have a slope and a point using point-slope form. Y minus y1 equals m times x minus x1. So I have y minus, my y1 is -1, equals, my slope is 1/5, x minus 2. So this is really y plus 1 equals, distributing that slope, 1/5 x minus 2/5. I'm going to subtract 1, equals 1/5 x. And then -2/5 minus 1 should always use a calculator, but this is -7/5. Right? 1 is 5/5. 2 minus 5 is 7. Okay, so 1/5 x minus 7/5. This will be the line that is perpendicular. That's it for today. I'll see you guys tomorrow.